Hello grade 12s, my name is Natasha Barton and I would like to welcome you to question number 2 of the November 2021 Physical Science Paper 2 exam. This question deals with organic chemistry. It is one of 3 questions on organic chemistry that you will normally find in a November paper 2 exam. Organic chemistry is a big section of your chemistry paper, so it is very important that you master it. Starting off with question 2, which is the basics, and building your way up to those reactions in organic chemistry. So question number 2 says, the letters A to H in the table below represent 8 organic compounds. And here we have different types of formulae and representations of molecules. A, B, and G are structural formulae. C, and well, only C, is a condensed structural formula. If we look at D and E, there we have molecular formulae, and F and H are the IUPAC names of compounds. Question 2.1 says, define the term unsaturated, an unsaturated compound. We say that an unsaturated compound is a compound that contains a double bond. Of course, it can also contain a triple bond like the alkynes. Or you can use the term multiple bond. It contains a multiple bond. Or you can say it is a compound that does not contain only single bonds between carbon atoms. And for writing this down, you're going to obtain 2 marks. Question 2.2.1 says, write down the letter that represents an unsaturated compound. We now know that an unsaturated compound is one that contains a double or triple bond. We call this multiple bonds. So if we look at compound B, we see that there's a double bond between 2 carbon atoms. Therefore, B is the correct answer. But if we draw out compound E, we have 2 carbon atoms. There are 4 hydrogen atoms, so we're going to place 2 on each carbon. When we are done drawing these hydrogen atoms, we notice that the carbons have only made 3 bonds, and carbon can make 4 bonds, so we can place an additional bond at the center. We now see that there's a double bond between the carbon atoms, and therefore, in answer to question 2.2.1, we could also say the answer is E. I'm, however, going to write out the letter B, and that is going to get us 1 mark. 2.2.2 says, write down the name of the functional group of compound C. So we go up to compound C, and we now need to analyze compound C. We see a whole lot of carbon and hydrogen atoms, but on the 4th carbon atom, there is an oxygen atom. That carbon atom is bonded to 2 other carbon atoms. So this means that we have a ketone with a double bond O on this carbon. And the functional group of a ketone is known as a carbonyl. So the answer to question 2.2.2 is carbonyl. And this is going to get you 1 mark. Question 2.2.3 says, write down the letter that represents a chain isomer of compound C. Remember, isomers are molecules that have the same molecular formulae. So they contain the same types of atoms and numbers of each type of atom, but their structures are different. We have 3 different types of isomers: functional isomers, chain isomers, and positional isomers. Chain isomers will belong to the same homologous series, and they will therefore have the same functional group. So since C is a ketone, we know that its chain isomer will be a ketone as well. Chain isomers differ by their longest continuous chain. So normally we will see that the stem name changes when we are looking at chain isomers. So when we go up to the table, we start off by looking for a ketone other than compound C. And since F is the only ketone, we know that F is actually the answer to the question. If you thought of choosing compound D, remember compound D only contains 2 carbon atoms. This oxygen atom will therefore fall on the first carbon atom, making it an aldehyde instead of a ketone. So F is the correct answer. You're welcome to count the number of atoms and the types of atoms in this compound, but we're just going to write down the answer F, and for that you're going to obtain 2 marks. Question 2.2.4 says, write down the IUPAC name of compound G. So when we look at compound G, we see that it contains a few special atoms, specifically halogen atoms. And there is no other functional group, so this is a haloalkane, also known as an alkyl halide. The names of haloalkanes end with the name ane. We now need to identify the longest continuous chain, and we see that the longest continuous chain here contains 6 carbon atoms, so we therefore use the stem name hex. Now we need to number the carbon atoms so that the chlorine atoms and methyl group obtain the lowest numbers possible. Whether we number from the left or the right, the chlorine atoms, or at least the first chlorine atom, will fall onto carbon number 2. But we also now need to take the methyl group into consideration, especially because the chlorine atoms from either side will begin on carbon number 2. If we start to number from the right-hand side, the methyl group falls onto carbon number 4. But if we number from the left-hand side, then the methyl group is going to fall onto carbon number 3. So numbering from the left-hand side gives the methyl group the lowest number possible. Now we need to name the substituents, the halogens and the branch. We start off with chlorine because according to the alphabet, C comes before M for methyl. So we write down the position. It is going to be 2,5. This is the position of the chlorine atoms. Di, please do not forget this prefix. Di means there are 2 chlorine atoms. We use the word chloro to describe the chlorine atoms. Then we need to indicate the position of the methyl group. This is the methyl group, or a branch. It falls on the 3rd carbon, and we therefore say 3-methyl hexane. In this case, you're going to get 1 mark for hexane, identifying the longest continuous chain. You're going to get your second mark, for the substituents, for naming them correctly. Your third mark you're going to get for the entire name being correct. So the 2,5 hyphen between numbers and letters, and of course having the correct numbers in your name, that is going to give you the third mark. Question 2.2.5 says, write down the general formula of the homologous series to which compound E belongs. So we go up to our table and we see compound E. Fortunately, we've already drawn out the structural formula for compound E. We see that it is a hydrocarbon. That means it only contains hydrogen and carbon atoms. This hydrocarbon contains a double bond and it is therefore an alkene. The general formula of an alkene is CnH2n. So for every 1 carbon, it contains 2 hydrogen atoms. For writing this down, you're going to obtain 1 mark. Question 2.3 says, define the term functional isomers. We say that functional isomers are compounds with the same molecular formula, but different functional groups, or we can say different homologous series, and this gets us 2 marks. Question 2.4 says, for compound A, write down the homologous series to which it belongs. So we go up to compound A, where we see on the very first carbon is a double bond OH. This functional group is called a carboxyl group, and It falls or can be found in compounds that belong to the homologous series called carboxylic acids. So carboxylic acids contain carboxyl groups. For writing down the word carboxylic acid, you're going to obtain 1 mark. Now question 2.4.2 says, write down the structural formula of its functional isomer. We're writing down the structural formula of compound A's functional isomer. For this section, it is very helpful to remember that ketones tend to form functional isomers of aldehydes and vice versa, while carboxylic acids tend to be the functional isomers of esters and vice versa. So since compound A is a carboxylic acid, we know that we would like to draw an ester that contains the same types of atoms and number of each type of atoms. The carboxylic acid, that is compound A, contains 2 carbon atoms, 2 oxygen atoms, and 4 hydrogen atoms. Of course, they're not necessarily bonded in this order. So when we draw an ester, we know that we're going to have our 2 carbon atoms. Between them must be the oxygen atom. On one of these carbon atoms, we need a double bond O. If we look at the first carbon atom on the left-hand side, we see that so far it has made 3 bonds. So 1 bond can be given, or the extra bond can be formed with a hydrogen atom. The carbon atom on the right-hand side is missing 3 bonds, so we're going to give to it 3 hydrogen atoms. And having drawn this, we've completed question 2.4.2. We're going to get our marks as follows. 1 mark for having the correct functional group. So as you can see, this is drawn between or in the center, right? So this oxygen is between 2 carbon atoms. That's your first mark. And your second mark is for the entire compound being correct. Question 2.5.1 says, compound D undergoes a dehydration reaction. Write down the IUPAC name of compound D. Whenever you're given a molecular formula or a condensed structural formula and you are asked to name the compound, I do suggest that you start off by drawing out a structural formula for the compound, because it may make it easier for you to name the compound. And you can do this on your question paper where the marker does not see it, so that they don't accidentally mark your structural formula instead of the name of the compound. So here we see that this compound contains a hydroxyl group. It is therefore an alcohol. We see that in the longest continuous chain is 2 carbons, making this compound ethanol. Now, some of you may have been tempted to indicate the position of the hydroxyl group, but if you did so, you may be penalized. And the reason for that is, no matter where you put this hydroxyl group, it will always be on compound number 1. Making its position obvious. The name of the compound is therefore simply ethanol, and that will get you 1 mark. Now question 2.5.2 says, write down the letter that represents a product of this reaction. We are dealing with a dehydration reaction, so we expect water to be the byproduct of the reaction. In order to answer question 2.5.3, I've drawn out a representation of the reaction so that you can better understand it. When we have a dehydration reaction, the alcohol loses the hydroxyl group and the hydrogen atom from a neighboring carbon atom. When these 2 are eliminated, they form water, but in their place is a double bond. So here we have ethene, right, and alkene, which we know is compound E. The very last question, so for writing down, the answer, we simply say E, and that is going to get us 1 mark. Question 2.5.3 says, we need to write down the name or formula of the inorganic reactant that is used in this reaction. In this reaction, we need to make use of sulfuric acid, which is H2SO4, or you can write out the word sulfuric acid. Specifically, it is concentrated sulfuric acid, but just for writing down either the name or the formula, you'll obtain 1 mark. This brings us to the end of question number 1, which is out of 18 marks. Question number 3 will be dealt with in the next video, and it is still on organic chemistry, but specifically in that question we deal with the physical properties of organic compounds, so intermolecular forces and the different types of physical properties that they have.